Hi, my name is Taesu Kim and I'm a PhD student at KAIST. In this video, I'll be talking about our work on EvalLM, an interactive tool for evaluating LLMs on user-defined criteria. This work was done with my collaborators Yoonjoo and Juho at KAIST and Jamin and Yoonjoo at Naver AI Labs. Advances in LLMs have allowed developers and designers to design and power a wide array of novel applications. These applications take input from users, combine this with the prompts created by the developer, and then input this to the models to generate outputs and drive new experiences in various domains. While LLMs allow developers to easily prototype applications as all they have to do is write a single prompt, actually improving and polishing these applications can be challenging. As LLMs are black boxes, it is unclear what prompts will consistently provide high-quality results. As a result, developers need to test various prompts through a process of blind trial and error. Considering this problem, we decided to interview various prompt designers across academia, industry, HCI, and NLP to understand how they carry out this trial and error and how we can better support them. With prompt designers here, I mean developers, engineers, or researchers who have designed prompts before. Our interviews showed that during these iterations, designers test their prompts by testing them with diverse inputs and generating multiple outputs. The designers then examine each of these outputs to check whether they satisfy various requirements or criteria that need to be satisfied for their application to function well. After identifying what is working or not in the outputs, the designers will then edit their prompt and repeat this process again. We found that as designers do not have the resources to hire external annotators, they frequently do this whole process of iterating and evaluating by themselves, manually. As they need to repeat this process multiple times, and this requires a lot of effort and time, developers mentioned how they are only able to evaluate a limited number of samples on a limited number of criteria. This means that they are unsure whether the prompts will actually work well in production. In this work, we envisioned an alternative workflow, where the developers defines their own criteria, then an LLM evaluates outputs on these criteria, and the user can then focus on verifying these evaluations instead of examining the lengthier outputs. We instantiated this process in EvalLM, a system for iteratively evaluating outputs from LLM prompts on user-defined criteria. This is the main screen in the interface. First, the user defines their task instruction, which explains what they want the LLM to do. In this case, the developer is creating an application that creates examples that explain scientific concepts to children. Then the user composes two prompts that they want to compare. Here they can use the token's instruction and the input, which are later replaced by the user's task instruction and the input data that will be used to produce outputs. In this case, the user creates two different prompts with different roles for the LLM, different formats, and different amounts of information. Now, to generate, the user first samples diverse inputs from their dataset by clicking on Sample Diversely. The samples are shown as rows in the middle of the interface. Then, by clicking on Run Prompts, the user can generate outputs with each of their prompts on each of the sampled inputs. These outputs are presented side by side so that the user can compare the outputs generated from each prompt for the same input. Now, the user can evaluate these outputs with the help of the system. For this, the user can create criteria from scratch by simply describing what they want the system to evaluate in the outputs. Additionally, if they can think of other criteria to evaluate, they can browse through the criteria dictionary to find criteria proposed by prior work and add this to their criteria set. After creating their criteria set, the user can evaluate all the outputs that have been generated by clicking on Auto Evaluate. When evaluating each pair of outputs, the system also looks at the task instruction, the input sample, and the list of criteria to then determine which output or prompt was better at satisfying each criteria. The system represents evaluation results as a table where each row is a criteria and each row presents three circles which show whether the first output was better in the criteria, if there was a tie, or the second output was better in that criteria. If their user wants to verify why the system returned these results, they can click on one of these rows to view the system's explanation for its evaluation. This panel also shows the scores out of 10 that the system assigned to each output on that criteria. To help the user check these explanations against the outputs, the system also highlights portions of the outputs that it deemed to be important when evaluating that criteria. These explanations allow the user to identify what they should improve in the output as well as whether the system interpreted the criteria correctly. In case the user identifies some criteria that needs improvements, they can directly edit the criteria's description. Or if they need help in thinking about what improvements to make, they can also use the criteria review tool. Clicking on this tool will automatically start an analysis of all the user's criteria to identify any criteria that may be redundant, too broad, or unclear. The system then provides suggested revisions, which are then displayed as badges next to the criteria name. The user can look through the suggestions to add them to their set by clicking on them. Since the evaluation results may differ each time they are run, the user can increase the number of evaluation trials to get more robust results. The system will then aggregate the results from these trials to determine which output was better at each criteria. The user can switch to the evaluations for each trial by using the carousel buttons below the explanations. By evaluating outputs, the user can identify additional aspects to improve in their prompt, and after revising their prompts and generating new outputs, the user can also identify new aspects to consider in their criteria. Through EvalLM, developers can repeat this process multiple times to iteratively revise and improve both their prompts and criteria in parallel. EvalLM also provides several additional features to support the prompt iteration process. The history feature allows users to keep track of all the prompts and criteria that they used previously and to check relevant evaluation results. The deployment screen allows users to automatically generate and evaluate large samples of outputs once they have gained enough confidence about their prompts and criteria. This screen also allows users to compare different LLMs as evaluators and to measure their intra-rater reliability to verify whether they agree and in what cases they disagree. Although prior work verified that LLM-based evaluations correlate with human evaluations, we conducted a technical evaluation to assess whether more fine-grained and task-specific criteria can improve the performance of LLM evaluations. For this purpose, we used the empty bench dataset, which contains human pairwise evaluations for the outputs generated from diverse LLMs. And we compared 3 different conditions on this dataset. The first condition prompted GPT-4 to assess the overall quality of 2 outputs to determine which one was better. The second condition prompted GPT-4 to select 3 relevant criteria to the input from a set of general evaluation criteria, and to then evaluate the outputs on each of these criteria. The evaluation results were then aggregated. The final condition was based on our approach, where we used an LLM to automatically split and revise the criteria selected for the general condition to automatically create a set of task-specific and fine-grained criteria. We measure performance on 2 metrics: agreement, which was the percentage of cases where the LLM evaluation agreed with the human evaluations, and flies kappa, which assesses the inter-rater reliability between the LLM and human evaluations. Our results showed that the specific criteria condition showed the highest agreement and flies kappa in relation to the human evaluations. By qualitatively analyzing some of these cases, we identified that by using more fine-grained criteria, the LLM was prompted to provide a more comprehensive and multifaceted evaluation of the outputs. Additionally, as the criteria were more specific to the task input, the LLM evaluations were more relevant and focused on the specific requirements of the task. Then, to understand how LLM-based evaluations can support developers' prompt iteration, we conducted a within-subject study where participants used 2 versions of the system. The sixth condition was the full version of EvalLM, where participants had LLM support for evaluating outputs and also for reviewing criteria. The manual condition was a version of EvalLM where participants had to manually evaluate outputs and they had no criteria review support. Participants were asked to design prompts for 2 different applications by using each of the conditions. One application had to generate examples that would help explain scientific concepts to young children. The other application was an interface that helped news reporters to think about different angles that they could cover about a specific story. In our study, we found that with LLM support, participants were able to evaluate a larger number of outputs and with much higher confidence. Participants mentioned how the LLM evaluation allowed them to look at the bigger picture of how their prompt was performing. They also mentioned how it helped them to quickly debug their prompts by helping them test changes and quickly see the results. Beyond simply automating evaluation, participants mentioned how the system actually helped them evaluate better themselves, as the explanations helped them to better see the differences in outputs from different prompts. In terms of actually iterating in the prompt, we observed that participants reached a relatively higher level of satisfaction in their prompts, without having to make as many changes as they did in the manual condition. Aside from helping them check whether changes they made were returning desired results, participants mentioned how the evaluations helped them to make smarter decisions about how to improve their prompt. Participants likened the evaluation explanations as feedback that helped them find where they could improve their prompts and also allow them to get diverse opinions about the prompts that they would not have been able to think about by themselves. In terms of criteria, we observed that while participants ended up with a similar number of criteria in both conditions, they made a larger number of edits when they had LLM support. This result shows how EvalLM helped the participants to better customize their criteria based on their own interpretation and needs surrounding the task that we had provided. In the production of LLM-based applications, there's a big gap between the development stage, where developers design and test their prompts, and the deployment stage, where these prompts are packaged into actual applications that are used by numerous users. As it can be costly or difficult to hire and recruit actual human users, developers need to painstakingly test and evaluate their prompts with their own manual effort and based on their own intuitions. However, with EvalLM, we can see how this can help developers to better test their prompts on bigger samples and with more feedback before having to invest significant resources into deployment or user study. Thus, we believe that EvalLM can help narrow the gap between development and deployment of LLM-based applications. EvalLM currently focuses on helping developers evaluate outputs from prompts on their own user-defined criteria. However, we can also see how beyond prompts, the system could help researchers and engineers to evaluate the models themselves by helping them define criteria for these models and verify evaluations of models on more outputs. Also, beyond evaluation, we can also see the potential of closing the loop by using the evaluation results to automatically refine or fine-tune LLMs, thus allowing for a sort of user-guided fine-tuning or refinement process of LLMs. For more information, please check out our project website or our paper. Thank you.